What is the smallest positive integer that only contains zeros and ones and is divisible by 36? Let's focus on that divisibility fact to start with. So to be divisible by 36, a number has to be divisible by both 9 and 4. You could go with 6 and 6, but 9 and 4 are good because they don't share any common factors. And therefore, we can use the divisibility rule for 9 and for 4 separately. If you go for 6 and 6, it's just actually it won't help. Or normal 18 and 2. All about the 9 and the 4. So to be divisible by 4, we need to look at the last two digits. And if the last two digits are divisible by 4, then the number will be divisible by 4. The reason for this is if you say have 97,136, we could write that as 97,100 plus 36. This number is necessarily divisible by 4 because it's a multiple of 100. 4 goes into 100. So it all comes down to these two, whether it's divisible by 4 or not. In this case, it would be. So that's a nice little fact if you were not aware of it, but that's the sort of knowledge you're expected to have in these kind of challenges. And then for 9, it's all about summing the digits. The digit sum must be divisible by 9. So I could write a number down like 2, 3, 4, 1, and then like a missing number. What would this number have to be for the number to be divisible by 9? If I add these up, I'll get to 10. So the only digit I could possibly put here for the number to be divisible by 9 would be an 8, because then it would add up to 18. Okay, which one should we use first? That's the question. And I think the last two digits it makes sense to use first, look at first, rather than the digit sum, because the digit sum is going to depend on the last two digits. Now there's only actually 4 options here. We can quickly write them all down. The only way this number is going to be divisible by 4 is if we put 0, 0 at the end. Okay, it definitely can't be odd, but with 10 if at the end, there's no way it's going to be divisible by 4 either. Because remember, 10, yeah, well, 10 is not divisible by 4. So it's going to have to end in a 0, 0. Okay, there's no way of getting around that. But we've now sorted it. As long as we've done that, we've got the 4 parts sorted. It's just about the 9s now. So we need the digit sum to be a multiple of 9. The smallest digit sum, therefore, smallest digit sum to give a multiple of 9 is therefore going to be 9. Of course, you could say 0, but we're not, it's not a positive integer, so it's definitely not something we're considering here. So right, we want the digit sum essentially to be 9. And if we include any more zeros, we're just going to make the number bigger. So we only want to include ones now, actually. In fact, we're going to have to include 9 ones. We need 9 ones, including any more zeros will make the number bigger without increasing the digit sum. So this is our answer. 9 ones followed by 2 zeros. The 2 zeros ensure divisibility by 4 has to be there. The 9 ones then ensure divisibility by 9. And it's the smallest number that could possibly ensure that because we have to have a digit sum of 9. So we have to have these 9 ones. All right, lovely question.